Good morning, everyone. How are you? Today we will start section 4, chapter 18, solubility equilibrium. Dr. Mustafa Al-Attar, chemistry teacher from the International School. Today is 6 April 2020, Monday. Now, I have to advise you to review section 1, 2, and 3 in this chapter to understand this section. The next slide is a preview of the section: objectives, solubility, product, calculating solubilities, precipitation calculations, limitations on the use of KSB. And you have to review KW, KA, K equilibrium, and today KSB, K solubility product. Our objectives in this section is to explain what is meant by solubility product constant, KSB, and calculate their values. Second objective is calculate solubilities using solubility product constant. The third objective, carry out calculation to predict whether precipitates will form when solutions are combined. But before we will start this section, we have to understand some important expressions. The first expression is solute. What's the meaning of solute? A solute is a substance dissolved in another substance. Okay, like table salt will dissolve in water. The second expression is solvent. Solvent is a liquid that dissolves a solid, liquid, or gaseous solute. So, water and table salt. Water is a solvent, table salt is a solute. The third expression is the solubility. So, the process of dissolving table salt in water is solubility. So, solubility is a chemical property referring to the ability for a given substance, the solute, to dissolve in a solvent. It's measured in terms of the maximum amount of the solute dissolved in a solvent at equilibrium is the maximum amount. So, the resulting solution is called a saturated solution. So, now, the next expression, a saturated solution, is a chemical solution containing the maximum concentration of a solute dissolved in the solvent. The additional solute will not dissolve in a saturated solution. So, if you have amount of table salt and you will start to dissolve it in water, you will continue to dissolve excess of the solute, which is a table salt, inside the water until the time of saturation. What's the time of saturation? The time at which you will start to see the solute inside the solution. It cannot dissolve. There is no more dissolving of the additional amount of the solute inside the solvent. The next expression is concentrated solution. What's the difference between saturated solution and concentrated solution? As mentioned before, and we understand what's the meaning of saturated solution, okay, concentrated solution is different. It's a solution that contains a large amount of solute relative to the amount of that could dissolve. Okay? So, you can get a concentrated solution, but not saturated solution. For example, if you have silver chloride is a solid, and if you dissolve it in water, a little amount of this silver chloride will dissolve in water. Okay, a little amount, because silver chloride is slightly soluble in water. So the amount which will release from the solid and distribute in the solvent, okay, this solution is called a saturated solution. There is no more particles from silver chloride to dissolve in the solvent. But saturated solution, the whole amount of the solute will dissolve in water until the time of the saturation, the time of no more particles can be dissolved in the solution or in the solvent. That means the full capacity of the solute to get solute, of the solvent to get solute. So now you can differentiate between concentrated solution and saturated solution. Okay, very good. Now, what's the meaning of miscibility? We have solubility and miscibility. Solubility mainly is referred to the dissolving of solid and liquid, but miscibility is referred to the solubility of liquid in liquid, or liquid gas in liquid, or other thing. Okay, so miscibility is the property of two substances to mix in all proportions, forming a homogeneous solid. Return to the concentrated solution of silver chloride. Silver chloride is heterogeneous solution. Why? Because you have solid substance inside, still inside the solvent, but small particles of silver chloride will distribute in the solvent. So the solution of silver chloride in water is heterogeneous solution. But in miscibility, the two substances will form homogeneous solution. The term is most often applied to liquids, but sometimes it can be applied for solids and gases. Okay, but it is small, very little examples. Okay, example of miscibility of water and ethanol. They are miscible because they are mixed in all proportions. So, dissolving of H2O with ethanol is not solubility, it is miscibility. Okay? This slide explains a saturated solution and concentrated solution. The next slide, this explains the heterogeneous equilibrium system of silver chloride. Silver chloride is a solid substance, and if it dissolves in water, it will slightly ionize. So this solution is, this solid is slightly soluble in water. We have solids that are completely soluble in water, like table salt, like sugar, and others are slightly soluble in water, like silver chloride, and other substances are not soluble in water, like glass with water. If you put a piece of glass, it cannot dissolve in or soluble in water. So silver chloride is slightly soluble solid in water. It will, the piece or the particles that will release from the solid silver chloride will ionize as silver ion and chloride ion. Okay, so we can calculate the solubility product constant, KSB, of what? Of this side. You remember the equilibrium constant? The equilibrium constant, we measure the two sides, the product side and the reactant side. But in this section, we are related only to the particles that will be ionized. So KSB is related to the products only. So here, the expression KSB is equal concentration of the products power to the coefficient. Okay? Without, and we will neglect what? We will neglect the reactants. So KSB equal concentration of silver ion power to coefficient 1 times concentration of chloride ion power to coefficient 1, as mentioned in this slide. This equation is balanced equation, so here is one coefficient. Ag, before Ag we have one coefficient, and before Cl we have one coefficient. Okay? So the numerical value of KSB can be determined from solubility data. Another example with another coefficient for a saturated solution of calcium fluoride at equilibrium state. Calcium fluoride is also slightly soluble in water. It is solid, so the particles that will ionize, a little particles that will ionize in the solution, calcium cation and fluoride anion. But here, to balance the equation, you have put before fluoride 2, because Ca is present in group 2 in the periodic table. So calcium fluoride is CaF2. Okay? It will ionize to calcium cation, calcium plus 2, and 2 fluoride anion to F minus 1. So the solubility constant, solubility product constant, KSB, equal the concentration of the calcium times the concentration of fluoride power coefficient 2. Sorry for this G is minus, is negative charge. It is not G, but I copy paste it from the digital axis as it is. So the solubility of CaF2 is equal, it is constant. It is constant at specific temperature, but if you change the temperature, the solubility product constant will change. Why? Because the situation will change. As we mentioned before, increased temperature may increase the solubility, increased pressure may increase solubility, increased concentration may increase solubility. Okay? So the solubility of calcium fluoride is 8.6 times 10 power minus 3 gram. Here is gram per 100 grams of water. So this amount in grams will be dissolved in 100 grams of water. Okay, you understand this point, because this is very important to solve problems, to solve practice. At a given temperature, which is room temperature, which equal 25 Celsius, expressed in mole per liter. So if we change it to moles per liter, this concentration becomes 1.1 times 10 power of minus 3 mole per liter. How can we change these grams per 100 grams of water to mole per liter? And as you know before, if you want to change the grams to moles, you have to do this procedures. I don't know now, to change number of moles, number of moles equal mass over molecular mass. Okay, so here you have 8.6 times 10 power minus 3, okay, grams. You have to change these grams to what? To moles. So you have here, you have the amount in grams, and you have in molecular mass. I'll give you calcium fluoride. Calcium equal 40 and fluoride equal 90. So calcium fluoride equal 40 plus 2 times 90. It will equal around 78. Okay, 78. So here you want to give or to bring or to found a number of moles. You have the mass, you will put here in mass over a molecular mass. So you will write equal mass 8.6 times, I don't know, times I can mention it like let us this times 10 power minus 3, okay, over what? Molecular mass, which equal 78 molecular mass of calcium fluoride. Okay, so this is the first part in this equation. This is the first part. Okay, the second part is 100 grams of water. You have to change now by this equation. By this equation, we changed this amount per grams to moles. The second part is to change 100 grams of water to liters. How? By dividing over 1000. Okay, so all these value, okay, all these value will multiply with what? You see here, this 100 grams is in the down. Okay, so you have to divide this 100 gram over 1000 gram to change this gram, this water, to liters. Okay, but if you exchange it to the top, okay, you have to revise the value. So in this case, if you multiply here, so you will multiply 100 over 1000. Okay, let us see the values of this calculation. Okay, sorry guys, you will multiply this 1000 over 100. Okay, you multiply these values, all these value, with this value. Why? Because this is the first part. Here you will exchange the grams to moles, then you will exchange grams of water to liter. Okay, but this value is down, so if you want to change it to or move it to top, you have to revise the location. Okay, so here now it is right. Now it will equal 1.1 times 10 power of minus 3. Is it right? We can see. Yes, it is right. Okay, let us see the book. I don't know how can we return to the book because I shared the yes, here. Let us see the book here. It's the same, but I prefer my my way. Okay, here this is the amount per grams over 100 grams of water. Cancel this value, you are not related to this value. But if you want to change these grams to number of moles, you have to divide it by molecular mass of the substance. And then if you want to change grams to liter, okay, you have to divide this 100 over 1000. So this 1000 will be in the top. Okay, it is the same. The two ways are the same and they will give the same results, but this is for silver chloride, but our example is calcium fluoride. Okay, okay. Return to our slides. So now we have the concentration of the ions, of the soluble ions. Yes. Okay, this is the steps which we already understand it. Firstly, we have to write the chemical equation. Secondly, we have to balance the equation. The third way, we have to write the solubility product expressions, the K SB equal concentration of the two products or three concentration of the products at all. Okay, then complete the solubility product expression by displacement of the values to the equation. Okay, so now calcium fluoride dissociates to yield twice as many fluoride, because according to this equation, each one calcium ion will dissociate with 2 ions of fluoride. So this fluoride, okay, this fluoride is not one fluoride, it's 2 fluorides. So you have to multiply this value times 2 before adding inside the brackets. So you have to put this value in this area, this for calcium ion. Then you have to multiply this value by 2 and put it inside the brackets, and the brackets will be power to 2 to the coefficient, because inside the brackets you are related to the concentration, but this 2 is related to the coefficients. And this equation, you have different concentration of the ions. This CaF2 will produce 1 ion of calcium and 2 ions of fluoride. So the equation will be like this. The concentration of calcium cation will be 1.1 times 10 power minus 3 mole per liter. And now you understand why mole per liter. But the concentration of fluoride is this value times 2. Okay? Then you can add the values to the solubility product expression. Okay? And this is mathematics. So the final value of KSB will be like this. You can use the calculator. So calculation of KSB ordinarily should be limited to 2 significant figures. So you have to write it to 2 significant figures. Okay, this is the first example. This table, if the examiner give you equation like this, they can supply with you by the important figures. Okay, we understand this, the solubility constant, and what's the meaning of solubility. We explained it in the beginning. Okay, sample 2. Calculate the solubility product constant KSB for copper chloride, copper 1 chloride, CuCl, given that the solubility of these compounds at 25 Celsius. So it should be at specific temperature. Okay, so now it will be the solubility is 1.08 times 10 power minus 2 gram per 100 grams of water. So you have to change this value to mole per liter. Okay, and you understand now how to change these values, gram to moles and grams of water to liter, by the same way as my way or this way. So this amount of calcium of copper chloride, copper 1 chloride, over 100 grams of water. Cancel this value. This is not important in the equation. Now you have to change grams to liter by dividing this 100 grams with 1000, and this 1000 will be in the top, and you have to find number of moles. So you will divide grams over what? Over the molecular mass of the copper 1 chloride. Okay, so this is the equation, and here this is the exchange, and this is the equation. Now copper 1 chloride solid will ionize or slightly ionize to copper positive 1 plus Cl minus 1. So KSB, the expression is equal concentration of copper times the concentration of chloride. So the concentration of copper equal chloride, because this is 1 mole and 1 mole, so it will equal the solubility in mole per liter. The value which will be found from this equation. So here, this is the value. This is the value. Okay, so copper, concentration of copper ion equal concentration of chloride ion equal this value. So you have to multiply these values 2 times to find the KSB. This is very easy and direct. The main issue here is how to change a gram per 100 gram of water to mole per liter. This is the issue, the main issue in these parts. Okay, by the same way, this is another example. Okay, but in this example we have a KSB and we have to find the X. Okay, so the solubility product constant can be used to determine the solubility of a slightly soluble salt. So you can get one of these parameters, and you have the KSB. The KSB, the examiner can supply you from this table, okay. Then you can write the expression KSB equal concentration of barium times concentration of carbonate ions, okay, then equal 5.1 times 10 power minus 9. Okay, so these two values are equal. So the concentration of barium is equal to concentration of carbonate ions, and we can put X instead of this value or this value. So KSB equal X times X, so it will be X square. This X square will equal this value. So X, you can find it by calculator. So the molar solubility of barium carbonate is 7.1 times 10 power minus 5 mole per liter. Okay, this is another example by the same way, okay, and you can find it by the same calculations. Now we finish this section, this part of this section, hoping to be easy inshallah, and in live section inshallah we will explain more and more and solve more practice. Thank you, see you, bye.